everyone, Mrs. Newmeyer here, back with our hands-on science, week 5. This week we're going to be doing 2 experiments. Now, a couple weeks ago we started talking about our skin and did an experiment with our fingerprints. We're going to be talking a little bit more about the skin today, so that's the one I'm going to do first. It's going to be from our Janice VanCleave book, number 77, called Rubbed Off. For this experiment, you're going to need a few materials we'll talk about in just a few minutes. But first, I want to show you the pictures to remind us about the skin that we looked at a couple weeks ago. Now, I have a different book today to show you the skin. Now, remember we talked about the 2 different layers that we were looking at of the skin. The dermis, which is the part underneath, and the epidermis, which is the very top part, the part that we observe when we look at our skin. The dermis was the lower layer down here that protects the rest of our body. Now, I want to show you this really cool picture right there, a section of the skin. Do you see in this first picture here, there's flakes. You see those flakes? That is a picture of what our skin looks like through the microscope. Interesting. Now, our first step in our scientific process is to ask some questions. And so that was kind of like we were doing some research already, right? We did some of our research before we even started asking questions. Because sometimes when we look through the books or we do start doing our research, it prompts us to ask those scientific questions. So one of the questions I have when I'm looking at this picture where I see those flakes is, do those flakes on my skin come off? And if so, then what happens? What questions do you have? When you look at the 2 different layers, the epidermis being the top layer and the dermis in the bottom layer, can you think of some questions that come to mind with your epidermis? Maybe look at your skin, observe your skin a little bit. Think about like when you're taking a shower or a bath and you rub your back or part, and maybe some of the skin peels off a little bit. What questions do you have? Spend a few minutes thinking about the questions that you have about skin. The scientific question I want to explore today is, do our epidermal cells rub off? Now, epidermal, that's the epidermis, remember? Those are the types of cells that we have on the top of our skin, the epidermis. So in our research, we saw a microscopic view of those cells, how they look flaky and they're on top. We saw the different layers, the epidermis and the dermis underneath. And so we've done some of our research already. Now, we can do a little bit more research by trying to figure out how might we come up with a hypothesis to this question. So, do our epidermal cells rub off? So our hypothesis, which is what? Bing! An idea we can test. So let's come up with our idea that we can test in our experiment today. Do our epidermal cells rub off? So my hypothesis might be, yes, they do, or no, they do not rub off. Now, some of my research is research that I've observed in my own life, like we talked about. Sometimes my skin peels, and sometimes, I have a skin disease called psoriasis, where sometimes it's on my head and I scratch it and then I see white flakes. That's the epidermal cells. Do they come off? They might. And if they do they grow back? That's might be when we would do some research. Let's go to our experiment. Now, for our experiment, we're going to need some materials. We're going to need a piece of sandpaper and a piece of paper. I'm going to be using is a darker sheet of paper because my bar of soap, which is another material I have for my procedure today, is white. And so when I am going to be looking at it, I want to be able to observe it on a darker sheet of paper. So gather up your materials and let's get started on our experiment. My hypothesis today is going to be, yes, that our epidermal cells do rub off. Because I feel like in my own experience, I've done some observations that they do fall off. And so I want to confirm that today in our experiment, because that's going to be my hypothesis. Is that the same as yours? it's okay if it's different because you never know what the results will be. That's why we do science experiments, to find out the actual results. Now I'm going to take my sandpaper and my piece of soap. Now we're going to pretend like our soap is like the epidermis, the upper layer of our skin. And when it encounters things like daily life and where our skin rubs against different things, we're going to try to replicate that by pushing our piece of soap onto our sandpaper and rubbing it up and down. And you don't have to do it very hard. And what we find is, what do you observe? Go ahead and give it a try. What did you observe? What I observed after I conducted my experiment is that pieces of the soap ended up on my piece of paper here. That when I was rubbing, the harder I would rub, the more would come. But even if I was rubbing softly, little pieces would fall off. Now, what does that tell us about our skin? Let's go to our analysis. What happened? What did we observe? We observed, first in our research, we saw that we've got cells on our skin that are small, tiny, little, separate little things, and that they come off. We observed that in real life. And then we saw the soap, and we saw that they fall onto the piece of paper. So in my conclusion, I'm going to say that our hypothesis that yes, our epidermal cells do rub off is correct. And my conclusion is that we are constantly shedding off our old skin. But the cool thing is that the new skin constantly is growing. So as you can see in this picture, this is the epidermis, this top layer here. This is the bottom of the epidermis, and below it is the dermis, the bottom part. So you can see the ridges that we talked about when we talked about fingerprints. Well, the epidermis creates new cells down here at the very base of the epidermis. And as time goes on, they go up to the top, and then they get shed off the top here, while new cells are constantly being formed, and they go up, 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 up to the top and are shed off. And so that cycle repeats. When you're young, it's usually around every 10 to 30 days, and as you age, it gets a little longer. But that is why we see the skin cells shedding off, and the new cells are replacing them. And that's part of like when we get a cut, why our body heals, is those skin cells are being replaced very, very quickly. And so just in a matter of days, your finger, say you get a cut on your finger or on your skin somewhere, it heals. Those new cells are constantly being replaced and kind of just continuing to slough off as new ones are being added. Our second experiment for today is going to be number 72, called Sound and Direction. Now we're going to be talking about a different part of our body, which is our ears. And we're going to be listening to some sounds and figuring out if we can tell where the sounds are coming from. Now, back to our scientific process, we've got a new scientific question for this new experiment. And first, let's think about what sort of questions do you have about the ear and how it receives sound. Think through some questions you might have, like why are some sounds louder and why some sounds softer? How do our ears receive those sound waves? Does it matter where the sound waves are coming from? Well, my scientific question I'm going to explore today is, can our ears determine the direction of the sound source? All right, our next step, remember what it is? It's research. So we have our scientific question, and we're going to do a little bit of research. And first, we want to maybe think about how our ears work. I'm going to look at a book here. This one comes from this book about senses. We're going to be using that this week and next week. Now we have a cartoon drawing of our ear here. Here's the outside of our ear, here's the inside of our ear, and here's what it looks like there, and then this is where it goes to the brain. Now, when sounds are made, it makes what are called sound waves. Here's some examples of different sound waves. They've made some funny cartoons here, but essentially it's a wave goes like this, and it enters our ears, and then let me show you this from another picture here. The sound waves enter our ear, and we hear those. They come as sound waves, and we hear it as a sound. So if I clap over here, I hear it coming, those sound waves coming in. If I clap over here, I hear those sound waves coming in. Now what happens if we clap in the middle? Do you think that it will change how I hear those sounds? Like, does it matter where the sound comes from, how my ear receives it? That goes with our scientific question today. So can our ears determine the direction of the source of the sound? I'm going to say, for my hypothesis, that's our step 3, bing, an idea we can test, right? So for my hypothesis, I'm going to say, yeah, I think that our ears can determine what direction the sound is coming from. So my hypothesis is yes. My hypothesis will be stated, ears can determine the direction of a sound source. So let's do some experimenting and see if we're right. Okay. Now you might have a different hypothesis, and that's okay because we want to test it either way. So for this experiment, you're going to need a helper. Now that can be your mom, your dad, your tutor, your brother, your sister, friend, someone around you. That's all. Those are your materials. And what we're going to do is you're going to have your helper sit down in a chair and close their eyes. You're going to make a series of sounds right in the middle. So you don't want it to be on too far on one side or the other side. You're going to be right in the middle so that the sound waves will go equally to each of the ears. And so it's going to look like this. Say I'm sitting in my chair. Say I'm the helper. So what you're going to do is I would have my eyes closed, and you're going to snap your fingers. Or if you don't snap, you could just do a little pat right in the middle, and you're going to do it on top of their head, maybe behind their head, in front of their face. Make sure not to get too close, but do it right in the middle. And you're going to see if they can tell which direction the sound is coming from. All right, go ahead and give that experiment a try. Pause the video, and when you're done, come back. Okay, what did your experiments show? What were your results? Could they hear it? Could they tell which direction it was coming from? Now, in my experiment, couldn't tell. It couldn't tell if it was coming from the right or the left. What about yours? Now, sometimes we might think it's coming from one or the other, but if you do this experiment enough times, and that's one thing about science is you want to be able to repeat it over and over and over and see if you get the same results. If you do this experiment enough times, you'll find out that no, they can't determine where it's coming from. Because when the sound is in the middle, the sound waves coming from it will be going equally in both directions. And so your ears, both ears will receive the same amount of sound waves. There won't be one more towards the other if it's right in the middle. But if we were to clap on one side, this ear would receive more of the sound waves than this one. So we would definitely be able to tell it was on one side versus the other. But when it's right there in the middle, the sound waves are traveling and are carrying all the way to our ears in equal amounts. So our conclusion is that when it's right in the middle, our ears cannot determine the direction of the sound source. And that concludes our experiment for today. Thank you for joining me, and we'll see you again next time. Bye-bye.